All right, everybody. Once again, I'm going to be going through some questions and answers, and in the process, I will explain some of the theories behind these questions. All right. The first question I have is about this section. Sometimes students find it difficult because there are a lot of multiplications and ratios and things like that. But the fact is, this is mathematical operations. If the mathematical operations are difficult, that doesn't mean chemistry is difficult. Remember that. So go and learn about those operations first, mathematical operations. All right, so they're asking how much heat, I'll put Q as the heat, how much heat is required to raise the temperature of something by, by 35 grams of iron. You have to raise the temperature from 25 degrees to 35. Asking how much heat, but they have also given specific heat capacity or specific heat of iron as 0.444 joules per gram per centigrade. Okay, so the formula is Q equals mass times the specific capacity times delta T. Delta T is given as always delta final minus initial. Remember, always the final, whatever in the scenario of what is at the end. So here we know this mass is 35 grams. You don't have to convert it to kilograms or anything because they are given in grams. So 35 grams and specific heat is given by 0.444 joules per gram per centigrade and times delta T. So it is from 25 to 35. This is the final, this is the initial. So 35 minus 25, I get 10 as the delta T. So I multiply by 10. Okay, what is it? Centigrades. Okay, so because these grams here, grams per gram cancels all things, and when you multiply, you get the answer 155 joules. That's how you get the answer. Okay, an exothermic reaction. So the question is about what is exothermic reaction? It is when the heat is released. Whenever there's an exothermic reaction, this delta H, which is enthalpy, it's a negative value. Negative. How do you get that? Final minus initial always. Delta is the change. Delta is Greek letter. Simple delta is like that. Okay, that is used to see a small charge separation. This is the change, the difference, delta. When I say delta, that's what it means. Okay, it's mean change in enthalpy is given by always final minus initial. Always. It is negative. That means initial. The compound, we say A becoming B. Say A had 10 and B had only 5. The difference is minus 5. Where is it gone? It is gone outside. That is why it is exothermic. It's given out. So it is always whenever exothermic, it is released. The heat is released. Okay. Determine the specific heat of zinc. So this one they're asking for zinc. Specific heat capacity. That's what they're asking. But they have given when 25 grams, that is the mass of zinc rod, was heated from 25 to 75. So this is the final, this is the initial. So the difference is 75 minus 25, 50. Mass is there. It absorbed 486 joules of heat. So if you write the formula, original formula, delta T is 50. Specific heat capacity is what they asked. Mass is 25. And you have to get the other one. Q is given as 486. Q, 486. Okay, so you have to find the specific heat capacity. It's an adjustment you do. Okay, let me write here. So I have 486 equals 25 times the unknown specific heat capacity times 50. So 486 divided by 25 and divide by 50. I should get specific heat capacity. And the answer I have here is 0.389 joules per gram per centigrade. I say per gram because it's under this line, right? Okay, so it's the same thing as writing joules gram. Okay, so some books you can say. So answer is 0.389. Normally, for almost all pure substances, the temperature increases. As the temperature increases, the density of the substance decreases. Why is it? Okay, so that the answer is asking whether it increases or decreases the density. Okay, so when the temperature increases, the density, remember, decreases for all pure substances. Okay, the reason is density is given by mass divided by volumes, right? Normally, when you increase the temperature, what happens? It expands, so volume increases. So if a denominator increases, the value of under this line, denominator increases, the total value is going to go down. That's why density. If you keep the mass constant, if you increase the volume, the density goes down. For an example, I divide 10 by 2, 5. Imagine it's the volume. Now I increase it to 5. I get 2. You see, there's a decrease from the top part, right? That's what it means. So almost all pure compounds, when you increase the temperature, the density decreases because it expands. Okay. Volume increases. That's okay. This is about a conversion. I'm not going to answer this because you can check your conversion table and you can do it. This is about converting 65 centigrades to Fahrenheit. You can put the formula and find it. Okay, we have done some questions, so it's time. We can convert it. Another one, which is the conversion about minus 233 centigrades to Kelvin. This is also, we have done it before, so go and do it, because otherwise be active learner, not a passive learner. So I'm going to do this because there's in the video I have done similar one. It doesn't matter what values, if you know the method, you can find it. Remember that formula. This is a question about what is potential energy, that is stored energy, potential. So if you lift an object, you give it energy because you are lifting it against the gravity, and the height gives that energy, right? So normally it's given by mass times gravity times height, you get the potential energy. Okay, but the question is, a skier waiting at the top of the ski slope exhibits potential energy. So a skier waiting here at the top of this exhibits potential energy, potential from this side to this side, that potential energy, right? It doesn't move. When it is moving, that is kinetic energy. It is moving. So here it is just staying at a higher place, that is potential energy. So because it's to do with gravity, you can be specific and say gravitational potential energy. But if it is a spring like that, you pull the spring or compressor spring, that is spring potential energy. Gravitation potential, this is spring. So this is, here it is gravitational potential. Energy within chemical bonds. So, like if you take a molecule and if you have carbon or something, these bonds, it doesn't have to be carbon, any atom, these bonds means it has energy there. That is a potential energy. So if anybody asks what is in chemical bonds has potential energy. Because when you're making a bond, the energy is given out. When you're breaking a bond, when you're going to break this bond, you have to give in energy. Right? When you're making a bond, it gives out energy. Higher the energy, that means the stronger the bond. To break, you have to give in energy. Higher the bond, more energy is required. So energy within chemical bonds is called potential energy. In the kinetic molecular theory, this is the question, which physical state has more empty space than matter? That is a gas. We have done it in the video. So gas has more empty space than a liquid. Liquid has more empty space than a solid. In the kinetic molecular theory, we will learn about those theories later. Kinetic molecular theory, which physical state has more empty space than the matter? It's a gas. Now again, the same questions coming. So how much heat is required to raise temperature of 38 grams of copper from 1 to 2 degrees centigrade to 246 centigrades? Okay, so you apply this equation. Okay, so I'm not going to do this calculations in detail. 246 minus 122, because this is T final, this is T initial. Okay, then times specific heat capacity they have given as 0.385 times mass, 38, then you get the answer. The answer I have here is 1810 joules. When at the for reaction, end of reaction, if you get a value that Q, the amount of heat, the energy in the form of heat, if you have Q like this, it means less than 0. Less than 0, that means it has a negative value, right? Means heat is exothermic and it's released, right? Because it's released, the final one will have within that less energy, less heat. So heat is exothermic, is released. That is why Q is less than 0, which means a negative value. Remember that. Right, this we're going to come to a set of questions on periodic table. So you should have the periodic table. And then from looking at the periodic table, if you have the information, alkali metals. So if you get a periodic table that gives all this information, normally it is the group. Remember that. Alkali metals in group 1. Alkaline earth metals. Halogens 7 or 17. Okay, 7A or 17A. They might, sometimes they have that letter too. Then noble gases. Okay, so remember those ones. Group 1 and 2 is you call S group, S block. Also use there is a non-metal. So you need to know periodic table. If you get the correct table, you will see the periodic table. You can have metals, non-metals. The metals on the left-hand side. When you go to the right-hand side, they become non-metals. So the list they're asking which is a non-metal, right? The question is non-metal. They have given a list. Molybdenum, copper, strontium, and selenium. So out of that, selenium is the correct answer, non-metal. Look at the periodic table, you will see that. All these things are metals. Selenium is the non-metal. One is they'll try to see whether you can read it. They say they will give you identify the element, find the element in period 6 and group 15 means or 5, group 6, right? So periodic table you count, say 1, 2, 3, 4, 5, 6, you go down, right? 6 and you go all the way and see where it is 15, group 15 or group 5. Take the last one. Then that's the element. So they have given a list like barium, osmium, bismuth. So it is, the answer is bismuth. Bi, bismuth. Okay. All right. Okay, so you have to know what properties are there in metals. Metals, the properties of metals. They have the shiny luster. So remember the properties, they have shiny luster. They are good conductors. They might be one or more, or ductile and malleable. Ductile means you can make wires out of it, like wiring properties, and malleable means you can hit it and bend it. Okay. Malleable. Malleable, ductile, and malleable. So those are the properties. So remember, it has a shiny, good conductor, ductile, and malleable. So I have to get rid of it. These are all, these questions I'm doing now seems to be about periodic table. Largest size. Largest. So is it an electron, proton, neutron, or an atom? Obviously, all these are inside the atom, so atom is the largest. Okay. A big question. So the question I have here is transition metals are placing electrons in which orbital? D, right? The orbital range is what we call transition metals. The orbital. The range of things and which one has the largest size. Largest size. You know that when you go across a period, the atomic size decreases. This is decreases. When you go down, it increases. So if they have given a range of calcium, carbon, I have here aluminum and oxygen. You have to see which atom has the largest size. Okay, so if you place these things in the periodic table, these elements, you will see that oxygen is here top. And calcium is in the 1, 2, 3, 4, in the fourth one. Calcium is somewhere here. Oxygen is in the second one. And carbon is next to oxygen here. And germanium is somewhere there. Okay, so these are the same groups, and then calcium would be the higher one. So when you go down a group, the size or the volume increases. When you go across things, it decreases because the same number of protons, higher number of protons have the force, or the will exert the force on the same shell, so it shrinks. Okay. So whenever they ask about which one has the largest size, you can arrange it in a way and find out. Okay, so whatever element, just look at the periodic table. If it is lower and towards the left hand side, that will be the largest. If this question asks the smallest size, then it is going to be oxygen. Okay, because oxygen is higher above and it is towards that place. So that is the decrease goes, right? It is going to the right side and it is up. So size is decreased. And then there'll be a question about, they will give you a random, because I'm going by the questions I have here. So I have a question here asking, they're asking what is the charge of barium? So what do? You look at the periodic table and see which group is barium. Barium is in group 2. So group 2 means it has 2 electrons in the outermost shell. That means they can get rid of 2 electrons, meaning it will give +2 charge. Okay. Another question about what is the charge of selenium. So if we look at the selenium, it is in group 16, or we'll say 6. That means in order to become 8, it can take 2 electrons. So it will have the charge of 2 minus. That's the reason, selenium. Okay. There's another question about here, the similar question. It's asking about, I'm very sorry about this term, alkali metals. Alkali metals, in which group? We know it is in group 1, or sometimes they might say 1. Remember that. Okay, so alkali metals. If it's alkaline earth metals, it's group 2, they might say group 2A. When you're given a list of things, you should be able to say which one is a metal or non-metal by looking at the periodic table. Here I have a question that which is a non-metal. They are given zinc, vanadium, and bromine. So out of that is bromine is the non-metal. Okay. Okay, so I have here asking, this is, you have to know the Roman numerals. Okay, so this way, if you do practice question, then you will learn these things. If you don't know, you can search and find out, but if you just go to the exam, then you will know, obviously. They're asking what element that's in period 3 and group EA. EA means 5A. That's what it means. Okay, so they are given a list of elements. Is it phosphorus? Is it zirconium? Sorry, not zirconium, tellurium, and MO. Molybdenum. So if you look at, what is it? Period 3. So you go down the period and go to the group 5, which means 15, and you will see phosphorus is there. So period 1, 2, 3, you go down the period, and then you go for the 15, then you will see it is phosphorus. Okay. Question we are asking, which atom is the largest? Largest size. So they have given cobalt, potassium, arsenic, and chromium. So the largest one should be the left-hand side and the low. So out of that, it's potassium, right? So look at the periodic table where they are. If they're on the same period, you can go towards left, and if they are in different places, you go to the lowest one. Left lowest would be the largest size. Sit to smallest size. There'll be a question about ionization energy. Ionization energy is the energy required to remove an electron from an atom. Okay. So which element has the largest ionization energy? Largest ionization energy, you need to know two rules. The ionization energy means like, okay, if I take sodium, sodium has one electron in the outermost shell, the valence, so it can remove that electron. That is the ionization energy. Okay, that energy decreases when you go down group because the more shells are there, so the electrons are far away from the nucleus. Attraction is less. Also, this in between these shells has the shielding effect. Shielding effect. Okay, it shields that effect. Then when you go across a period, ionization energy increases because more protons are adding, right? As we go from left to right, more protons are adding. That means more force is there to hold these electrons. So the ionization energy increases that way from left to right. So if they're given a list of the things like Ge germanium, right here, Ge carbon, lead, and tin, stannous. Which element below has the largest ionization energy? You could see from here, if you go to the right and up, ionization increases this diagonal. So carbon would be the one that has the largest ionization energy. Okay. Right. What is an expected charges from gallium? Yes, what is the expected charge from gallium? What you do is you go to see which group. Gallium is in group 13 or 3A. That means it has positive 3. That's how you check it. Afternoon, everybody. Last question. What charge is expected of iodide? Iodine, iodide. So if you go to that, it is in group 17 or 7. That means there are 7 electrons in the valence, so you can take 1 electron. Okay, which means it will have -1 charge for iodide. Naming compounds, you know that iodine becomes iodide because it has a charge. Now it is an anion, negative charge. All right, everybody. That ends these videos. For that, I will be starting the range. So the next video would be video 6. So far, I've done 5 videos. These would help you to do your exams, I hope, because once you understand the theory, application is the same for whatever the question they ask. All right.